Okay, so development of B cells from stem cell all the way to a mature B cell can be kind of broken up into these stages, and there are 6 major stages from early pro-B to immature B cell. Stem cell is where you start. Dr. Lint talked about your germline DNA. You're going to want to notice where in these stages the germline DNA is rearranged. Because there's 6 stages here, and a curious person like me likes to ask questions about stages. And devoted studying minds like yourselves might have the answers, right? Okay, so the majority of B cell development is going to address the first goal, generating a diverse antigen receptor. So that should clue you in as to how important that goal is. So remember that it's technically an immunoglobulin, but while it's attached to the surface, it's called a B cell receptor, BCR. You'll hear me say that a couple of times. What class is the BCR? Does anyone remember? It's the very first heavy chain you get. IgM. We always start with IgM. If you have something that says it's IgG or IgD or IgA, it is not your initial immature receptor, right? Okay, the other 2 goals, which address self-reactivity and promotion and maturity, those are handled in later stages and often once it has left the central lymphoid tissue. Okay, so let's get into the meat of things. So we have our stem cell or our common lymphoid progenitor, whichever you want to call it, and it's gotten signals from the B cell, that's from the bone marrow, that say you're going to become a B cell. Your destiny has been planned. So it goes off to little B cell school. And remember the antibody structure that Dr. Lint talked about. You have 2 heavy chains, then you have 2 light chains, and they're all held together by that hinge region, that hinge joint. And he talked about how it happens on like a molecular level. We're going to talk a little bit more on the cellular level, okay? So the first rearrangement happens on the heavy chain, and it's both D and J, okay? So both D and J rearrange on both chromosomes. This is essentially a foot race. They're both going to start rearranging. They're going to see who gets the job done first. Almost all of them will be able to do this, so that's fine. But all we have is D and J. Once it rearranges D or J, it goes from being an early pro-B cell to a late pro-B cell. So at the late pro-B cell, this is where we start exercising that concept of allelic exclusion. Okay, so Dr. Lint talked about this a little bit. Remember, you get 1 chromosome from mom, 1 from dad. For a heavy chain, you get 1 and 1 for a lambda, 1 and 1 for a kappa, right? So theoretically, you have 6 chromosomes capable of being part of VDJ rearrangement here. So remember, the first one that actually got D to J is going to tell the other one, sit down, my turn. I won the race. I get to keep rearranging. So that one's going to try to do V to DJ, all on the heavy chain. We are only on the heavy chain right now. If it is not successful, the second chromosome says, ha, you failed. I get to try now, okay? So now that's going to try to do V to DJ. If that can't do it, the cell will die. The default process of lymphopoiesis is death. 50% of the cells will die. So most of the time you're losing cells because there are various stages, and more will die in future stages. This is really a story about death. So the first chromosome, let's say the first chromosome was successful, it will be signaled to survive and become a pre-B cell. And at that point, the other VDJ chromosome, the second chromosome, is never going to get a chance. It's done because we finished rearranging our heavy chain. If it wasn't successful, then you go to the second chromosome. If that's successful, it goes to the pre-B cell. So I have this little bomb up here. So I like to think of diversity as an explosion, okay? Especially with B cells, because they're really diverse and they're constantly changing. So remember back to your cartoon watching days. It's Saturday morning, you went and got yourself some, I don't know, some Cookie Crunch, and you turn on cartoons, and you've got Wile E. Coyote, and he's always trying to kill the Roadrunner. The Roadrunner's too smart. maybe this is just me, maybe I'm too old and you guys didn't watch this. You guys were watching like Pokemon or something. But anyway, it was a great cartoon. Look it up on YouTube. And the Wile E. Coyote is constantly ordering from the Acme Corp TNT, because he's just going to blow up the Roadrunner. He's got a real like death wish for this bird. And the reason I like that is that the TNT looked just like that. Remember, Dr. Lint mentioned TDT, which is an enzyme. TDT adds in N nucleotides. So it always makes me think of the Roadrunner going meep meep, and it makes me happy. But this happens on the heavy chain, and only on the heavy chain, really. So this is where you get in these N nucleotides that explode diversity at this stage, okay? All right, so we rearranged a chromosome, we got a heavy chain, we have a functional heavy chain, it's got some N nucleotides. It's now going to go from being a late pro-B cell to a pre-B cell. And this is a really important stage. So this is the equivalent of a kid getting training wheels on their bike. So you were riding around on your tricycle, you've grown up, you're ready for a big kid bike. Your parents didn't just like stick a helmet on you and say, see you later, kid. No, they gave you training wheels. This is where we get the surrogate light chain. The surrogate light chain is the B cell's training wheels. So we went through rearranging our heavy chain. We need to test if that heavy chain is any good. And by this, we mean we need to know, is it going to pair with a light chain? Is it going to be able to make that connection? Because if it can't, there's no point in going forward. One problem, we haven't rearranged our light chain yet. So we don't have a light chain. So what it does is it synthesizes these proteins, V-pre-B and lambda-5. V-pre-B and lambda-5 look like a light chain, and they pair with a functional heavy chain the same way a light chain will, okay? And we don't want to go through the process of making a light chain if our heavy chain is bad, because rearranging a light chain is an arduous, energy-sucking process, both for the cell to do and for you guys to learn. I'm sorry, it's just kind of annoying. But it is important because you have to learn this V-pre-B and lambda-5 to make sure that it's okay for your heavy chain. The B cell will also make these invariant chains, Ig beta and Ig alpha. These are basically signal transduction side chains, and they will be with our B cell until it becomes a plasma secreting cell or it dies, one of the two, because they're always dying. All right, so this light chain does a couple things. For one, it makes sure that the heavy chain is good. So that's a checkpoint. That's checkpoint number one. Did you make a good heavy chain? We're gonna assume we did. Two, it's what tells the other chromosome to sit down. You don't get to rearrange because we've got a good heavy chain, so we're successful. Three, it explodes our diversity again because this cell is gonna proliferate. It does not have a light chain, but it does have a heavy chain. So that means every single heavy chain of the same, so I'm one heavy chain right here. There's gonna be 100 of me. We're all gonna make different light chains. So I'm using that same piece of genetic material, that same rearrangement, to make 100 different types of me. So kind of like 100 different fraternal twins, okay? All right, so the other important thing about this pre-B cell receptor that's really gonna help you remember this stage. So if you happen to be in a room where people are asking questions and somebody says, well, this cell is expressing a pre-B cell receptor in an enclosed vesicle, not on the cell surface. An enclosed vesicle, not on the cell surface. You know it's a large pre-B. And if for some reason in your exam, say, you don't answer that, I have created a bat signal in ExamSoft that allows me to like apparate into the room, smack you upside the head and leave, okay? All right, so we all know that at the pre-B cell receptor, it's not on the cell surface, it's in the enclosed vesicle, okay? All right, so we did proliferation, right? Because we had our surrogate light chain, our pre-B cell receptor, and it signaled, and we made 100 fraternal twins. we're gonna follow one of my twins all the way to as it becomes a small pre-B cell. That's the next stage. And that's where we actually do light chain rearrangement. So remember, we have 2 kappa light chains, right? 2 kappa chromosomes and 2 lambda chromosomes. So we do allelic exclusion again. We're re-expressing RAG. Remember, that's that enzyme that allows for VDJ rearrangement. So we're going to re-express that, but we're going to do it 1 chromosome at a time. Tell the other one to sit down and be quiet. We're going to try to rearrange kappa on the first chromosome. If that doesn't work, we'll go to the second chromosome. If that doesn't work, we'll go to lambda. If that doesn't work, lambda again. If that doesn't work, death. Death again. Scourge on a population, all right? So this will also increase diversity because right now it looks like you get 4 shots at this, right? You get to do it on each chromosome. But wait, there's more. There's a lot of different V regions, right? Dr. Lint talked about how there's a bunch of V regions, there's a bunch of J regions. So let's say we're still on chromosome number 1. There are actually 5 J kappa regions and 4 J lambda regions. I don't expect you to remember those numbers, but I'm saying this just to point out that this cell could make repeated rearrangements on its light chain. So V kappa 1 to J kappa 2, it wasn't productive. And by not productive, what I mean is it can't bind to a heavy chain. We already made our heavy chain. There is no going back. That ship has sailed. But the light chain we can keep editing because we're still in the process of that. So if that didn't work, now we go to a second VJ region. So we've got V kappa 2 to J kappa, say, 4. If that doesn't work, V kappa whatever to J kappa 5. And you do that till you either run out of material or you move to the next chromosome. And when you've gone through all your 4 chromosomes, you've had your time, now it's done, okay? Yeah, okay. All right, so we made our light chain. We made our light chain and we've protected ourselves, right? So now we're gonna become an IgM kappa or an IgM lambda. So remember, I'm saying Greek letters here because we're talking about the specific chain, okay? So theoretically, this is an Ig mu kappa, right? Because it has a mu heavy chain and a kappa light chain. Always remember kappa first, then lambda, just like singing your ABCs, K comes before L, right? Okay. This is an immature B cell. It expresses its receptor on its surface. So the pre-B cell receptor is not on the surface. The fully rearranged receptor is on the surface, right? And that's an immature B cell. Okay, so we're gonna